Hi, I'm BD at Satic USA American Engineering and Manufacturing. Welcome to our show. With me today, I have our lead engineer, Dr. Bradley Layton, PhD engineer. Welcome to the show, Brad.
Thanks a lot, BD.
All
hey,
right.
everybody.
So what we're going to do today in just a couple of minutes is hopefully answer some frequently asked questions. It's recently come to our attention that there's a video that exists that states that our products don't work, they don't reduce dirty electricity, or what many call dirty electricity, and that the unit draws 6 amps of power. So we're going to talk about that today, answer some frequently asked questions, dispel some common misbeliefs, and then show you just on a live demonstration on a lot of meters that we're very familiar with in the dirty electricity world, and show you how the product works. First of all, Dr. Layton, I'd love to talk about our engineering team because it's something that we're very proud of here at Satic USA. The first engineer I'd like to talk about is Brian Jackson. So Brian Jackson has an MBA and an engineering degree, and he was actually an engineer for Idaho Power. Now, Brad and I spent a lot of time working with utilities, with the power systems engineering team for a couple of large server farms, cryptocurrency miners, and where that power comes from and how effectively it's used is very important to us. We live on this planet, so we like to see renewable energy sources as opposed to coal or something like that. So getting an engineer from the utility space, we felt was very important to add to our team. It seems like he also knows a lot of co-ops, the co-op owners, and the co-op members. He's also done millions of dollars of wind projects.
Right.
He's actually kind of a fun Google. So we'd love to have Brian Jackson on the team. The second engineer that I'd like to talk about on our team is Brian Havlovic. Brian Havlovic in Montana is a bit of an engineer of note. We have some manufacturing here in Montana that we're pretty excited about, and some companies that have developed some pretty unique tools. He actually worked on the brushless motor design that ended up in some Craftsman hand tools and an expanded version of a very similar motor. We all like to borrow things in engineering. Ended up in the Tesla automobile. We're exceedingly proud of that. Brian actually helped us with Gen 1 and Gen 2 of the products that we have. And Dr. Layton here is one of our newest additions, and he is our lead engineer. Dr. Layton got his undergrad degree in mechanical engineering from MIT. If you know about the engineering world, if you've ever seen the program Big Bang Theory, you know that several of our heroes are from Caltech, while Wolowitz is from MIT. And in the world of engineering, you can give a good argument either way on which is the finest university in the world, not just the United States, for engineering, and Caltech and MIT are near the top of that list that nearly everyone would make. I'm going to brag him up. Go ahead.
Yeah, and then I did my PhD at the University of Michigan in biomedical engineering under Anne Marie Sastry. And I guess Michigan's no slouch either. I think it's good known for its football, but it's got great.
So I'm a football guy, and we know Michigan's fantastic at that, one of the best ever in the history of the game. But if you've got Caltech and MIT up here, well, what are 3 and 4? I think Purdue and Michigan are probably right there.
They're always right up there.
You could give a compelling argument either way. So our lead engineer has an undergrad degree from MIT, grad and PhDs in engineering from University of Michigan, another top school. Now, the way Bradley and I met is I actually recruited him pretty forcefully because he was a professor at Drexel University.
Yep.
In Philadelphia in mechanical engineering, and then the University of Montana College of Technology at the time had an energy technology program, which we loved here at Satic because we need a lot of technical people. We don't need more engineers on the team right now. We love the team that we have, led by Dr. Layton, yet we needed technical people to help assemble and manufacture the products that we have. And so the internship program from Dr. Layton's program was great. I think we did 20.
About that many, students came through, and it was great having that relationship right here in Missoula. They loved coming out, great place to work, and then they always came back to the program knowing things that I couldn't teach them. So,
wow, what a gracious compliment that was. And when that program changed a little bit, it was important for us, in my mind, as the leader kind of the company here, to add a star engineer to our engineering team. So some of the things we're going to talk about, first of all, is dirty electricity. That's a term that's used a lot, and it has several definitions, and I won't get too technical in that, but what we've got behind us are some meters to give us a rating on what is commonly referred to as dirty electricity. We would usually call it maybe harmonics, interference, distortion, etc. We are not going to use the oscilloscope because Dr. Layton will go down a rabbit hole. It's more complex than even I'm willing to grasp right now. We'll make the video too long. We're going to use a Stetzer meter. It's a very common meter for measuring what many call dirty electricity. The green wave meter. We're going to add a few more things. We've got a P3 kilowatt meter that most of us are familiar with. We've got a current cost meter. And we just have an amp meter. So let me go ahead and light these up. Now what we're going to see on the meters initially is just the raw power in this state, this current setting, coming through Satic USA on whatever leg this power is on. Now, Dr. Layton, will you please describe these meters to us really quick and what we're looking at?
Sure, we'll go through the background. So the first one, this is just a Harbor Freight, just a $20 meter. It's going to tell us amps, it's going to tell us volts, it's also going to tell us wattage. Up here, the current cost meter. This is something that if you're interested in sort of knowing your instant electricity consumption as well as your projected monthly cost, you can get one of these for your homes. These two are more specific to the dirty electricity world. Oh, the same thing is also true of the P3 back here as the current cost. These two, the green wave and Stetzer, are more specific to the dirty electricity world. So a lot of our customers will buy these once we plug in the Satic unit, once we see these numbers come down. So the green wave is measuring millivolts, and that's millivolts of dirty electricity.
Yeah, no, I want you to hear what he says because that's good stuff.
Dirty electricity in the millivolts, and that's the amount of voltage above your normal 120 sine wave. So that's a millivolt range. On the Stetzer, it's a Stetzer unit, and it's more measuring how quickly that voltage is changing. Two separate units. The millivolts is actually that actual unit, Stetzer in its own unit, but the numbers that vary between 0 and typically 2,000, sometimes higher, give you the amount of so-called dirty electricity on your lines. That's what we're going to demonstrate.
I love it. Thank you, Dr. Layton. Turn the power strip back on so we can hear Dr. Layton.
So we're starting in just a background of about 400 on the green wave, and the Stetzer is kind of coming up, approaching the 300 range.
Now, one of the things that we had talked about when the video was released and our products didn't work is we asked, well, what are your standards for testing? What is your background or baseline? The reason we asked this is because these units right here are an impact of everything that's running in our facility. Is that true?
That's right, and even in the local grid.
So what our neighbors are doing has an effect on this. So if I'm really going to do a scientific study, wouldn't I have to create a really flat baseline that would be consistent?
Sure. I mean, you'd want to either you call the utility and say, do this, have all your neighbors turn things off, or somehow go off grid, which wouldn't be realistic.
It wouldn't be really practical. So let us show you this in real application. So right now, we're in the demonstration room, obviously, shooting a video. Right next to us is our CFO's office, right, the booking office, where we have Dylan. Hey, Dylan, would you do me a favor and throw on the lights really fast?
Oh, there was a flash.
Did you hear it?
Yep.
So just by turning on the fluorescent lights in the office next to us, what happened to our numbers, Dr. Layton?
It went up into the thousands, so almost triple what we were seeing.
So for a second, it really flashed. This guy was at 400. He's at 580.
Oh, right.
Wasn't he in the 300 range?
Sure. Yeah, and staying there as well with the lights on. So, and he's sticking right around 550, 560, and same thing here.
So if you're going to measure something, you really need a base standard. Dylan, would you turn the lights off, please?
Yep.
There we go.
Back down.
Right back down to where we were. So down to this 400 range and this 300 range.
Right.
So when you're conducting a scientific test, it's really important that you keep all things equal, because if the air conditioner comes on, we have 6 of them in this building, it's a large building. If one of our 3 refrigerators comes on, that could potentially affect by quite a bit the results of our test.
Soldering stations, all of that.
Soldering stations and all that. So let's go ahead and reset these for a baseline. So this one immediately gives its score. As Dr. Layton said, this is measuring how many times over a time period. So it takes a second to ramp up as it does the math, does the math, does the math. Is that correct?
That's right.
Okay.
That's right.
So what we have here behind me is a 5 amp air conditioner. We have the standard Satic unit, but what we've done, we've been a little naughty. We gave a clear lid just because we want the viewer to see what exactly we're testing, because it's important to show everybody exactly what you're testing, how you're testing it, and what you're testing it on. So one of the unique things that was said, I guess, in this video is that the Satic unit draws 6 amps of power,
Right.
and that he's an electrical engineer. You are an engineer, aren't you, Brad?
Right.
And so, how do we measure power? Would you say amps is a measure of power?
We typically measure in watts. We measure in watts. Electricity, horsepower if you're talking engines, but power is always measured in watts or kilowatts, but never in amps. Amps is a measure of current.
Amps is a measure of current. So is the total current, how much of that total current maybe is real power, or are there other types of power?
Right. So what we see, when you multiply volts times amps, you get watts. So voltage times current gives you power. And what you want when you plug something in, your hair dryer, your fridge, etc., you want that true power or real power. But on the other hand, if you're just letting electricity flow through a line like a garden hose and never watering the lawn, for example, that's called apparent power. And that's not what you want. You don't want to pay for it. And a lot of times the power company will actually penalize you for that. So these meters will also measure that apparent power. So that's what we're about to see.
And in residential, they don't charge for apparent power, or they try not to.
Typically not.
So you can't say always or never, because even in Missoula, we live in a small community, there are 3 different utilities, and they all have slightly different billing styles, billing rates, billing tiers.
And they change all the time.
And they have different meters. So the old Edison meter that we grew up with only billed you for that real power. So amps is very misleading there, as would be apparent power. As we're going to show you, what you'd be billed for ideally is just the real power, or true power as it's often called, which actually creates work. So let's give you a demonstration of that. So first of all, let me turn this back on. All by its onesie, this 5 amp motor has how many amps, Dr. Layton?
Just about 5, right at 5 amps.
Just about 5 amps. So a 5 amp motor drawing 5 amps, that checks out. We also have a CT clamp to the current cost. Now, this is apparent power. Now it says watts, but this is really all the power. I was often taught this was called total power, but the technical world is apparent power.
Right.
It's apparent because we can see it.
Right.
And how do we arrive at this math, Dr. Layton?
So we're just going to multiply volts times amps again and get watts. And as you can see, our 5 amps times, approximately 100 watts, or 100 volts, sorry, is 600 watts.
That's right. So we've got a 5 amp motor or load and a 120 outlet. So you can see 120 down here. What's 5 times 120?
600.
600.
There we go.
The math checks out. Now this says $42 per month, but most utilities using the old meter wouldn't charge you for all this because it's not all true power. We're going to talk about that next. Okay. So now we're going to turn off our 5 amp motor, and we're going to get to the bottom of the Satic unit draws 6 amps of power.
Right.
Power is, amps is current, amps is not power, watts is power. But that's okay. No, I'm just going to plug it in. Okay. So now we're just going to read the Satic unit all by itself. And what do you got?
Just the Satic unit, no motor, we're at 4.3 amps.
Okay, 4.3 amps. So 4.3 times 120 is about 500.
Right.
Again, it checks out. So your brain is now saying, or mine certainly is, 5 amps from a motor plus 4 amps from the Satic unit. What's 5.4?
It's usually
5 plus 4.
It's usually 9.
It's usually 9. It took him a PhD from one of the finest engineering schools on the planet. I'm really proud. Okay. No, just teasing. I often tell him that I got a 3.95 in school, and what's he saying? Yeah, but you went to tech. It's hurtful. It cuts me deep. Okay. It's laughing with me right now. Okay. So if we had 600 watts before, we have 500 watts now. 500 plus 600, obviously.
Just the Satic unit.
1,100.
Right.
So when we put them together, it would seem that we should see 9 amps and 1,100 watts. So is that true? I don't know. Let's see. That's the normal math. Okay. So back now, just to the motor by itself.
Right.
We're back to that 600 watts. We're back to that 5 amps.
Right.
So let's add the Satic unit. Whoa.
Okay.
Wait a minute now. 5 plus 4 is 9. 5 plus 4 is not 1.5 amps. Wait a minute. How's our 5 amp motor running on 1.5 amps? Well, that's 172 watts. Now, 1.5 times 120, 170. Brad, it checks out.
Works out.
So now, what are we seeing on our Stetzer meter and on our green wave meter, Dr. Layton?
Oh, well, so our green wave went from 460 down to about 50, 52, And the Stetzer, which was up in the hundreds.
350, I think I saw.
Yep, up in the right around 50 as well.
Right around 49.
This
So
is with both units on, with the motor running.
With the motor running. Now this is not just a filter on the load.
Mm-hmm.
This is with the motor running. So we're 5.5 plus 4 should equal 9. It actually equals 1.5. And where 600 plus 500 should equal 1100 equals 167. So what's happening? So we've drastically reduced the current, and that was probably the true power all along.
Mm-hmm.
So the Satic unit does not draw 6 amps of power. It has amperage of reactive power that is available that simply needs a load, simply needs somewhere to be usable.
That's right.
So what we've done, I hope that you know that we've not affected any of these meters at all. We bought them all off the internet. We have them plugged coming through our P3 into a power strip. We've cut a hoop in the power strip. What is happening here truly is happening. Every result's going to be different because having the lights on or off in your place is going to have an effect on it. But this is what happens here. In fact, what I'd love to demonstrate to you really fast is if we were just to plug in this guy by itself, you'll see the huge drop. So now we're down to 8 on this guy and 21 on this guy. And even if I stepped out of the frame and plugged it in somewhere else, I can't. If I can't move, I'll be out of the frame. It will work there too, because it really doesn't matter. So one of the things that we want to dispel too is, where's this coming from? Is the utility doing this to me? Is it my solar array? Or am I making it? Where does dirty electricity generally come from, Dr. Layton?
Well, there's two main sources that are line voltage, what we're looking at right now. And that can either come from the utility, so it's coming from outside the building, or inside. You can also make it right there with any appliance that you use. So those are the two main line dirty electricity sources. Also, we also see it, your entire electrical system in your house also acts like an antenna. So it can also come in either from your wireless devices inside or wireless signals coming from the outside. So that's a total of 4 separate sources.
Dig it, I agree. So why don't we demonstrate this again? Let's go ahead and turn these rascals back on. We're back up, we're holding pretty tight to this 400 range here on the green wave meter and about 300 on the Stetzer meter.
Right.
Dr. Layton, would you please add a compact fluorescent, CFL, compact fluorescent or curly Q lamp to the load and see what happens?
Okay, here we go. Very yellow.
Well, very yellow. So immediately, this guy went up a little bit, although not as much as we normally see. So we're not going to edit this video or the camera. I'm just going to tell you, Dr. Layton and I have done this demonstration a couple times. And while he only went up 20, he usually goes up several hundred. Would you agree?
It might have gone up by 10%, 10, 20%.
And so in this unique moment, we're getting something different. That's why it's so important to set up your processes when you're doing a scientific study. Dr. Layton, let's go ahead and turn off the CFL, and let's add an LED that I bought from a store we all know and love, or we all know and use.
Oh,
boy, I heard that. Did you guys hear that? So what are we seeing now?
We almost tripled. So we went from 400 to 1100 on the green wave, and we're above 500 on the Stetzer.
Okay, LED stands for what? Light emitting diode. So does a diode operate on alternating current or direct current?
It's gotta be DC.
It's DC. So all the things that we plug in that have a battery or have diode in them, normally speaking, are going to be direct current. So direct current is going to create what many call dirty electricity. Now, this has got over 1,000 on the green wave meter and over 500 on the Stetzer meter. And most people don't have one light bulb.
Right.
Most people, you have multiple light bulbs. Department of Energy says you might have 30 light bulbs. And so this is a compounding effect. Is that true?
Mm-hmm.
Okay. So let's go ahead and turn that rascal off and let these baseline again. Okay, we're back to
mid-4s and just below 300.
Okay, so at Satic USA, American Engineering Manufacturing, we call these guys culprits. We call solar inverters and DC devices and dirty lights culprits because they add to dirty electricity. Do you want to know the easiest way to remove your dirty electricity or lower it? Get rid of your culprits. Do you need to buy a filter tomorrow? If you can afford a filter tomorrow, I don't care what brand you buy, add a filter to your load system, right? Or be conscious of that. But the first thing that you can do that costs you nothing, start getting rid of some of these culprits. Let us show you the LED that Satic manufactures.
There we go.
Should see no change. So we saw a reduction here. We were about 300. What do you see now, Dr. Layton?
Yeah, it's 260 or so it actually came down to 70. Yeah,
70,
down by
280. So
10%.
what happened? So rather than adding dirty electricity, our unit actually can lower it consistently. And you get 30 or 40 of these guys in the home, you're really going to quiet a lot of that dirty electricity. And you didn't buy anything unique. You're going to buy a light bulb anyway. As you can see here, it had actually kind of a small increase. It's saying 5 or 6 decrease. It's actually saying reduction. But I saw that bouncing, and I want to be absolutely fair. Go ahead and turn it off again, Dr.
Sure.
Layton. Yeah, so you actually see some of these numbers go up.
Yeah, it's kind of in the noise.
It's in there a little
a few
bit.
percent.
So what I want to close with, thank you so much for viewing. We're not going to over edit this. It is what it is. One of the things that we're probably most proud of, we just started our 12th year. Do our products clean electricity? Well, we have over 85,000 installed. We have a 12-year track record manufacturing products in Montana for global export. When you check our Better Business Bureau rating, we have an A+. We actually have 1 complaint in our 12 years, and we forgot to call him back. And you want to know what? We're guilty.
Right.
We forgot to call somebody back. It didn't have anything to do with whether our products worked or not. It was a human failure and error, and we admit it freely. We did call him back, and now if you read that review, he's very happy and is grateful for everything because we overdid it. We are humans. But you know that if you have 85,000 of something installed in today's social media market, clearly it performs. Our Facebook reviews are 5-star, our solar reviews are 5-star, and our Google reviews are 5-star only. To date, it's the only review that we've gotten. And so thank you so much for that. Thank you, Dr. Layton.
That was fun. Thank
for
you.
putting some time on the camera today.
Yeah.
Thank you for watching.
Okay.
Bye-bye.